Look up at the night sky. Those tiny wandering lights are planets. Worlds, just like Earth, but different. For all of human history, we've been bound to this one world, our cradle and home. But what if we could change that? What if we could give a distant, silent world a voice? This isn't just science fiction. Scientists and dreamers are asking these questions right now. The universe is vast, filled with countless planets, most hostile, but some with potential. Spreading to other worlds isn't just adventure, it could be our ultimate survival strategy. Think of early explorers crossing unknown oceans, driven by curiosity and hope. Today, our oceans are the distances of space, and the new lands are planets in our solar system. We are on the verge of becoming a multi-planetary species. The journey will be long and full of challenges, but the reward is staggering, a second home for humanity. This journey begins with a single powerful idea: we can become gardeners of other worlds. The laws of physics can be used to shape our destiny among the stars. The cosmos is waiting. Are we ready to answer its call? What do we call the process of fundamentally changing an entire planet, altering its very nature? Terraforming. It's a grand vision, a concept that captures the imagination. Terra means earth. Forming means to shape, to mold, to create. So, terraforming is literally earth-shaping, but on a cosmic scale. It's the process of fundamentally changing another planet's environment, taking an alien world, its atmosphere, the very air it holds, temperature, making it warmer or cooler as needed, and surface, the ground beneath our feet, to make it more like Earth, a place where life can flourish. Imagine you're a cosmic gardener, arriving at a barren world, a blank canvas in the vastness of space. The soil is wrong, devoid of nutrients, there's no water, no life-giving moisture, and the air is unbreathable, toxic to human lungs. What do? You get to work, embarking on the ultimate construction project. Instead of shovels, your tools are giant space mirrors, reflecting sunlight to warm the planet, greenhouse gas factories, releasing gases to thicken the atmosphere and trap heat, and maybe even comets to deliver water, icy messengers from the outer solar system. The goal: create a place where humans could one day walk outside and breathe freely without the need for spacesuits or artificial environments. You need liquid water, flowing rivers and vast oceans, a thick enough atmosphere to protect from radiation and maintain pressure, the right mix of gases, oxygen to breathe, and nitrogen to balance it, and a stable temperature, avoiding extreme swings between hot and cold. This isn't a quick job. It's a project that will span decades, even centuries. We're talking about changing a world that's been the same for billions of years, a geological timescale. It would require immense energy, far beyond what we currently produce, advanced technology that we can only dream of today, and patience spanning generations. A commitment to the future. Terraforming is the slow process of giving a dead world a heartbeat, nurturing it back to life. It's about applying biology, chemistry, and physics on a planetary scale, a symphony of scientific disciplines. The ultimate test of our knowledge and will, pushing the boundaries of what's possible. It's the biggest construction project imaginable, dwarfing anything we've ever attempted. And it all starts with a single idea, a spark of inspiration. We can change worlds. We can shape the destiny of planets. When we look for planets to terraform, to transform into habitable worlds, we naturally start with our closest neighbors, the planets within our own solar system. These are the worlds we can realistically reach with current or near-future technology. Mars and Venus. They're our celestial siblings, born from the same stellar dust cloud as Earth, but they grew up very differently, taking drastically divergent evolutionary paths. Mars is a frozen red desert, a seemingly lifeless expanse of rusty rock and ice. Venus, a scorching, toxic inferno shrouded in thick clouds of sulfuric acid and a crushing atmosphere. Neither is welcoming, presenting immense challenges to any potential terraforming efforts. But both hold clues to a more Earth-like past, and possibilities for the future if we can unlock their secrets and overcome the obstacles they present. Mars is farther from the Sun, cold, receiving significantly less solar energy than Earth. It has a thin, carbon dioxide atmosphere, offering little in the way of breathable air or protection from harmful solar radiation. But it has water ice at its poles and underground, a vital resource for any future colonists or terraforming endeavors. And a day is almost as long as Earth's, providing a familiar and potentially manageable day-night cycle for future inhabitants. Venus, on the other hand, is almost Earth's twin in size and mass, a tantalizing fact that suggests it may once have been a much more hospitable world. but it's the hottest planet in our solar system, with surface temperatures hot enough to melt lead. This is due to a runaway greenhouse effect, and an atmosphere that's so dense, the pressure would crush you instantly. Its clouds are made of sulfuric acid, a corrosive substance that rains down on the planet's surface, and a day lasts longer than its year, meaning the sun rises in the west and sets in the east, a truly alien experience. Mars needs to be warmed up, its temperature raised significantly to allow for liquid water to exist on the surface. It also needs to be given a thicker atmosphere, one that can trap heat and provide protection from radiation. Venus, conversely, needs to be cooled down, its extreme temperatures brought under control, and it needs to have its atmosphere replaced, the toxic gases removed and replaced with something breathable. Both tasks are monumental, requiring technological advancements that push the limits of what's currently possible. By studying them, we learn about our own planet's delicate balance and the factors that make Earth habitable. Choosing which to focus on, which planet to dedicate our resources and efforts to, is a great question for the future of space exploration, a decision that will shape our destiny among the stars. Each world is a challenge and a lesson, teaching us about planetary science, engineering, and the very nature of habitability. The stakes are high, representing the potential for expanding humanity's reach beyond Earth. But so is the potential reward, a new home for humankind. Which world would you choose? Mars, with its familiar day and accessible resources, or Venus, with its Earth-like size and potential for a radical transformation? When we gaze up at the night sky, our attention is often drawn to our celestial neighbors. Of our two closest planetary companions, Mars consistently captures the most attention and sparks our collective imagination. And this fascination is for good reason. The allure of the red planet is undeniable. Mars feels tantalizingly close to being habitable, a world that, with a little help, could potentially support life as we know it. It's like an abandoned house with good bones, full of potential waiting to be unlocked, a fixer-upper on a cosmic scale. It has a solid surface providing a stable foundation for future settlements. The gravity is manageable, meaning humans could potentially adapt and thrive without significant physiological challenges. And a Martian day, or Sol, is almost as long as Earth's, making it easier to adjust to the rhythms of life on another world. But perhaps the most exciting thing about Mars, the element that truly fuels our dreams of colonization, is water. And the good news is, there's a lot of it. Vast quantities are locked in polar ice caps, a frozen testament to the planet's watery past, and even more lies hidden underground, a potentially accessible resource for future Martian inhabitants. Having readily available water on Mars means we wouldn't have to shoulder the immense cost and logistical nightmare of shipping it from Earth. Mars also possesses an atmosphere, however thin it may be. While it's thin and unbreathable in its current state, it's primarily composed of carbon dioxide. This is useful for warming the planet through the greenhouse effect, a crucial step in making Mars more hospitable. The red soil, or regolith, contains a wealth of minerals and elements that are essential for life, only needing the addition of water and organic compounds to potentially support plant growth. Mars isn't a blank slate devoid of character. It's a world brimming with valuable resources and a rich, geological history etched into its very surface. Furthermore, it's significantly more accessible than Venus, our other neighboring planet. We've successfully landed rovers that traverse its surface and deployed orbiters that constantly monitor its environment. We've meticulously mapped its surface, creating detailed topographical charts, and conducted extensive studies of its complex geology. In fact, we know more about Mars than any other planet in our solar system, with the exception of our own Earth. This wealth of knowledge provides us with a significant head start in our quest to understand and potentially transform the planet. All of these factors combined make Mars the prime candidate, the most logical choice, for our ambitious first attempt at large-scale planetary engineering, a project that could redefine our place in the cosmos. It's currently a cold, silent world, a seemingly desolate landscape, but beneath the surface, it whispers of a past, a time when rivers flowed and lakes shimmered under a warmer sky, and more importantly, it holds the tantalizing promise of a future where those rivers and lakes could return, transforming the red planet into a vibrant, life-sustaining world once again. Mars is our red hope, a beacon of possibility in the vast expanse of space. The dream of a second home for humanity, a new chapter in our story, begins here on the rusty plains of Mars. Turning Mars into a new Earth would be humanity's hardest challenge. The first problem, the cold. Mars averages minus 62 degrees Celsius, colder than Antarctica. We'd need to raise the temperature by at least 60 degrees to melt ice and keep water liquid. The second hurdle, the atmosphere. It's far too thin to protect from radiation or trap heat. We'd need to release carbon dioxide from the ice caps and soil to thicken the air and trigger a greenhouse effect. But Mars may not have enough CO2 for a breathable atmosphere. We might have to import gases, a mind-boggling task. And Mars lacks a strong magnetic field, so any new atmosphere could be stripped away by solar wind over millions of years. The scale of these challenges is almost beyond imagination. How could we actually do it? Scientists have wild ideas. One, detonate nuclear devices above the poles to vaporize ice and release greenhouse gases. Controversial and risky. Another, build giant space mirrors to focus sunlight on the ice caps, melting them in a controlled, clean way. Or, set up factories to pump out super greenhouse gases, warming Mars over centuries. No matter the method, this isn't a quick fix. Warming Mars enough for liquid water could take hundreds of years. Then, we'd introduce hardy microbes and lichens to start producing oxygen. Over thousands of years, these pioneers would change the atmosphere. It's a project for our distant descendants. Terraforming Mars is a marathon, not a sprint. Now let's look at Venus. If Mars is the fixer-upper, Venus is the teardown. Venus's size and gravity are almost identical to Earth's, a big advantage. But the problems are monumental. The surface is a blistering 465 degrees Celsius, hotter than a pizza oven, thanks to a runaway greenhouse effect. The atmosphere is 90 times thicker than Earth's, crushing and toxic. To make Venus habitable, you'd have to remove almost all its carbon dioxide, over 400 quadrillion tons, and you can't just vent it into space. Venus's day lasts 243 Earth days, with months of continuous daylight and night creating extreme weather. Changing the rotation of a planet is beyond our current technology. The scale of cooling and atmospheric removal is staggering, yet Venus's gravity and size make it tempting for the far future. For now, it's a vision of what can go wrong with a planet's climate. Venus is a warning and a challenge. How could anyone terraform Venus? The ideas are even more ambitious than for Mars. First, cool the planet, perhaps with a giant sunshade in orbit, blocking sunlight and slowly lowering temperatures. Next, deal with the carbon dioxide. One idea, bombard Venus with hydrogen-rich asteroids, turning CO2 into water and graphite, or introduce minerals to lock CO2 into solid rock, reversing the greenhouse effect. These are chemical engineering projects on a scale we can barely imagine. The most realistic near-term idea, floating cities in the clouds. 50 kilometers up, the temperature and pressure are Earth-like. We could build airship cities drifting in the habitable layer shielded from radiation. These cloud cities could be our first foothold on Venus. Could we really do it? Turn Mars or Venus into new Earths? Maybe, but not soon. The technology is far beyond us, and the effort would take all of humanity, working for thousands of years. Even if we could, should we? These worlds have their own beauty and history. Are we explorers or conquerors, gardeners or invaders? The dream of terraforming teaches us how precious Earth is. Our planet is a cosmic masterpiece. Protecting it should be our first priority. The dream pushes us to learn, to reach, and to ask big questions about our place in the universe. The journey to the stars begins with the choices we make today. If you could change another world, would you preserve its wonder or plant a new garden? The future is in our hands.